this one isn't anywhere near as bad as it seems. We'll draw a free body diagram of her right here. Well, actually, we're drawing her center of mass, which is up there. So here's your center of mass. Here's mg pointed straight down. Then we have these two ropes pulling upward on her, like this and like that. We'll call it T number 1 and T number 2. And that's all that's going on. So we put in our two axes. There's the x-axis. This was the y-axis, and this is the x-axis. And we need to find the angle between each of our slantways vectors and the x-axis. So we look at this and we see that this angle here is 10. That angle, we draw our x-axis down here. This horizontal there is like this one. We see that that angle there is alternate interior with this angle here. So that means this angle there is 10. Now, it said that she was halfway in between, and if you do some geometry and think about it, you'll realize that this triangle has to be isosceles, and so this angle up here also has to be 10, so this angle down here also has to be 10. So now we're ready to write our two equations. Just like a similar example we did with the hanging sign in class, in the x direction, all we have is the two slantways vectors, minus t1 cosine 10, because it's to the left, plus t2 cosine 10 equals 0. And from this, we're going to conclude that t1 is equal to t2. So I'm just going to call it t from now on. And then I write the y equation. I'm going to have the mg, which is flat on the y-axis, that's going down. And then these two vectors are up with, so they're both going to be positive, and we're going to use sine of 10. So we have plus t sine 10 plus another t sine 10. And again, that's equal to 0 because she's not moving at the moment. So this leads us to 2t sine 10 is equal to 0. So t is equal to, not equal to 0, is equal to mg. So t is equal to mg over 2 times the sine of 10.